Okay, let's deal with some of the other elements of the structure of a dynamic program. So we have the stages, little t from 1 to capital T, total number of stages. Now we notice another thing on the diagram. We have the lines, which are the stages, the dotted lines, which have the cities on them at that particular stage. So the cities are the states. So we have states, which are indicated by S sub t. And in this particular case, it's the city that you're at. It's the information that you need to know in order to decide what to do next. It's a little subtle because it's not data. It's not like the numbers of the problem, but it's like what is the fundamental information, dynamic information that I need to know. And in this particular case, it's where am I? And from that point on, now I can draw in whatever data I need. So it's not data, but it's some aspect of the problem, which is what you need to know in order to be able to make the next decision. And that brings us to the decision. Now, in our diagrams, the decisions are shown by the arrows. So the arrows show us where should you be going next, and we can say that maybe that's the flight number. So let's decisions, which we will indicate by X sub t, and that might be the flight number. So the flight number tells you take flight number AC 120, Air Canada 120, which takes you from Toronto to Calgary. I happen to know that, but or from, I think, the other way around, from Calgary to Toronto. So whatever, it's a flight number which tells you which action, what should you do, which flight should I take. And that's pretty well the variable names, no, not all of them. So these are the fundamental building blocks. So if you're asked to give a dynamic programming model, you definitely have to include what the stages are, what the states are, and what are decisions. And you're highly encouraged to use the same symbols as we've used here. Now the next thing that you need to deal with are a few relationships, functions. Okay, so let's start with one fundamental function, which is the transition. The transition is the function which lets you know what the next state, what's going to be the state that you will arrive at, that you will get to in the next stage, and we'll use the letter G, and that can be different for that transition function can be different for every stage, and it's a function of where you are and what you've decided. So given any given decision xt, given any state st, then in dynamic programming, this gt tells you where are you going to end up next time. Now in this particular case, it's kind of trivial. Given that you're in a particular city, you take a particular flight, you're going to get to another city. It could be in a chemical process. You could have a state variable, in fact, which could be a vector, which has all kinds of properties of the pressure, the temperature of different parts of the plant at a particular point in time, and then depending on that state, which is a vector or a matrix, and you make a certain decision, then that's going to tell you, maybe that's a solution of differential equation to tell you what state you're going to get to in the next period of time that you've defined for yourself. So these are very general concepts. We will not be stretching and nowhere close the concept in terms of the problems that we do, but certainly enough problems that you get the hang of what it is what a dynamic programming model is. So that's the transition function. The next function is something called the immediate consequence. And the reason I say consequence is I don't want to make a benefit or a cost, because that could be either. So we say the consequence. And the immediate consequence, it can vary. We'll use the letter H, can vary from each stage, and it's a function of where you are and what you do. So given that you are at a particular city and that you take a particular flight to another city, then the immediate consequence in this example would be how much money will you be making, what profit will you, what revenue will you be making in the next city, given that you're there now and you take that flight, minus the cost of getting to that city. That's the immediate consequence. It's a very myopic because it concept, because it does not take into account the future benefits to be had from that city onwards. So the immediate consequence is not shown, in fact, in this diagram. It's inferred. What is shown is a cumulative consequence. And that's usually indicated by the letter F. And it'll be F sub t. And it will only be a function of the state. So what we've done here, let's say the 416. The 416, the way the 416 was derived by saying, okay, suppose that I have a choice. I can either fly to the city of 342, the 376, 285. The immediate benefit will be the profit in that city, minus the cost of getting there. By the way, I've changed my mind in terms of when you get to LA, you have to work. So this 342 is the profit to be had in LA minus the cost of getting there. And then this is the profit to be had at that destination minus the cost of getting there. And this 416 accumulates. So if you like, the 416 minus 376 is the immediate benefit of flying from that city to that city. And that one gave you, that resulted in the highest value here. So the best decision was to go to that city with 376. So if we are recording these 416s, 512s, 422, that's the cumulative consequence. And those keep on growing as you move from stage to stage until you get to the end point, all totally at the right-hand side of the picture, upper and right side, 3212, when you get to PEI. Then you know F of 1, because you're at the first stage, and you are in PEI. You know what the initial S of 1 is. So I think we've introduced both a bunch of terminology that applies to dynamic programming problems. We will next finish off the structure of the dynamic programming problem.